Okay, so let's jump into the today's session. So today we are into the third session in the fourth module, that is wireless security. And today we will be talking about attacks and vulnerabilities in wireless networks. And quick recap to the last session. In the last session, we discussed about basics of authentication and encryption. We have looked at RSN information element, where the RSN information element contains the list of ciphers supported by the access point, the pairwise ciphers and the group ciphers used to encrypt the broadcast or multicast traffic, and pairwise ciphers are used to encrypt the individual traffic between the access point and the station. And RSN capabilities also contains information whether the access point supports 802.11w or not, protected management frames. And we can also see the list of authentication mechanisms supported by the access point, whether it is configured to PSK or enterprise. And we have also seen that different enterprise authentication mechanisms. We have seen how the 802.1x evolved over the years. We looked at various authentication mechanisms in enterprise like the PEEP, and we also looked at TLS, TTLS, what are the difference between TLS and TTLS. And coming to the very fundamental and very important part, for a handshake, we have seen how the data gets encrypted between the access point and the client device. So how this protocol establishes encryption between both the devices. Initially, the authenticator will send its nonce, that is called A nonce, and then the supplicant will send its nonce, that's called S nonce, and then both of them will have all the necessary entities to derive their own keys, and then both the devices will derive their own keys, that is PTK, and they will also derive GTK keys for encrypting broadcast and multicast traffic. And once they both derive their own keys, they will verify whether the keys match or not on both the devices using message integrity check. And once they get the confirmation, so all the data will be, the devices are good to go, right? They can exchange data and it will be encrypted. So even though somebody is sniffing over there, they will not be able to make any sense, right? Unless they have your passphrase or four-way handshake that they captured. And we also looked at the importance of radius server. So if you are a residential user and maybe you might have 6 or 7 devices that are connected to the access point, in that case it's fine. But in an enterprise scenario, there might be multiple devices that are connected to a single AP, and putting all the authentication load on individual on access point might not be a very good idea. So they have come up with something called radius server, which takes care of authentication of all the devices within the network in a centralized fashion. And then we also looked at the demo in the last session. The presenter demonstrated, right? We looked at in detail how the four-way handshake happens, how is the message flow between the authenticator and the supplicant. We also looked at the difference between TLS and TTLS, right? In TTLS, there is no client certificate required, but in the PCAPs, we have seen that client, the radius server is also validating the client certificate. And yeah, these are all the things that have been covered in the last session. And now let's jump into today's session. So basically, what are wireless network attacks? So putting this in simple terms, wireless network attacks are techniques followed by malicious users, attackers. So they will follow some techniques in order to gain unauthorized access to your network. So they can gain unauthorized access to your network, and they may exploit your resources, right? So you might have very confidential data within your network, but they might come up with ways in order to steal your data or crack your passwords. And some of the examples include wireless eavesdropping. So this is very basic attack where the attacker just passively listens to all the frames that are flowing over there. And let's say if you are connected to an unsecured network, right? If you are connected to an open authentication, then basically none of your data is encrypted, and the attacker might just listen to all the frames that are flowing around there, and he can basically see what are all the websites that you are visiting, and he can see the data that is flowing, and it's just he can basically monitor all your activity. So this is wireless eavesdropping. And the next attack includes wireless jamming. So Wireless jamming, think of it, you are stuck in a traffic jam, right? So when you are stuck in a traffic jam, why are you stuck? Because you do not have any space to move within the road, right? You are surrounded by vehicles. You have gone very congested. The same thing happens in wireless jamming. So whenever the attacker snips over there, he can basically know the channel that your AP is operating on. And once he knows that, he knows the range of frequencies that your AP is operating. So he can basically introduce RF interference using another sources, or he can introduce the same WLAN traffic over the air within your network proximity. So ultimately leading to the degradation of your network performance. So your throughput might be affected, right? We cannot stop interference from other RF devices if he has provided it, if he has very powerful RF sources. Then rogue access points. So have you ever connected to internet open authentication because just thinking that it is free? Well, some of you might have done that in public places like airports or railway stations and so on. But please be mindful before doing that, because the data is never encrypted between the access point and the client. So the attacker might intentionally set up an access point which has open authentication. So he can basically track all the data that is being exchanged between your device and the access point. So if you are visiting any websites and entering sensitive data of your email or password, basically you can monitor all that, right? And it is even more worse if you are connected to HTTP websites. You can see everything in plain text. The next thing is web4 WPA cracking. So today's session we'll be having lots of demonstrations as well, and this we will be demonstrating in today's session, where we will be seeing an attack in order to crack the Wi-Fi password that is set on, that is configured on the network. So we will be looking at the demo in today's demo on this one. Evil twin attacks. So what are evil twin attacks? Let's say this device is your original access point, and the attacker will come up with another access point that might not necessarily look physically the same, but it will resemble the access point in terms of the SSID, and he can spoof the MAC address in order to make you think that both of these are basically the same. And unknowingly, if you connected to the fake access point, you are under attacker's control, right? And what do I mean by spoofing? Basically, he will manipulate the frame that he is sending over there, and he will change the MAC address of the fake access point to the original access point. So your device might think that both are the same, right? And we will be also demonstrating the authentication flood in today's demonstration, where the attacker might again spoof the MAC address of the access point and send out a broadcast message. So clients might think that I need to de-authenticate because AB is asking me to do so, and which is not the case, right? And the attacker is doing that to break some service interruption. And the next we'll have man in middle attacks. So man in middle attacks is one of the interesting scenarios, and why we use a technique in order to gain access to the network. So you have your client device and you have your access point. So ideally, what should be the scenario? Both of them will be talking to each other. So it's like the communication is between just both of the devices. So what happens in man in the middle attack? The attacker will be spoofing. He will be sending a frame to client saying that I am the access point, and to the access point he will be saying I am the client device. So if there are for example, there are techniques like ARP poisoning, where he will send an ARP request to the client device by spoofing the MAC address with the AP's MAC, and to the AP he will be sending an ARP request by spoofing his MAC address as client device, and both the devices will update their ARP tables, thinking that the access point will think that he is the client, and the client will think that he is the access point. Now, how the topology got changed? Instead of they both communicating directly, the attacker came in the middle, in between both of them, right? So he can basically listen to the traffic exchange that is happening between both the devices, and with some techniques he can even manipulate the data. So basically, if the phone, in simple terms, if the phone is sending that you are good to the access point, he can listen that and he can modify that, right? Instead of saying you are good, he might say you are bad to the access point. So that is a possibility in man-in-the-middle attack. And we also have replay attacks. So what are replay attacks? You might have listened to this, right? Record and replay. So what is record and replay attacks? Uh, so you just press a button on your car keys and your car door will open, right? So what's happening in the background? Your car keys are sending an RF signal at certain frequency, and if the attacker has a device that is capable enough of listening to the surrounding RF signals, so this can be done using some RF instruments like hacker, and he will record the RF signal. So he will basically record that pattern, and he can, since the device is a trans receiver, and he can basically generate the signal again. And if the signal is captured properly, and he can replay it as many times as he wants. So this attack is like where even though the attacker does not have any of your car keys, he can basically open your car keys since he has that RF signal recorded. And so these are some of the attacks that we listed in today's examples, but there are, since the network is wireless, it's not physical medium, so attackers might come up with various ways in order to intrude your network and steal your data for their own personal benefits, or in order to exploit your network resources. So with this being said, and we'll be going into denial of service attack. Now I request Gopi to demonstrate this attack for all of us.
Yeah. Thank you, Simon. That was a great introduction, and you have seen a lot of lots of different attacks, right? So we will go through a few of them, and the basic attack is denial of service attack. So denial of service attack, what does that mean? So you are denying, you are stopping the service to a network or to a people, to number of people. Okay, so imagine there is employees in an enterprise network, okay, and they got connected to an access point. Okay, like normally, and then if you take a company, they will have a bunch of employees, and they will access the network via connecting to the access point, like normal, right? So in the middle, okay, an attacker will having minimal knowledge on Wi-Fi. So attackers like whoever do these types of attacks, okay, they don't need much knowledge. They don't need to be pro Wi-Fi, and they just go to YouTube and search for how to do denial of service attack on an access point. Okay, they'll get bunch of videos, right, and they'll watch one video and they'll try that type of attack. So in order to do these types of attacks, attackers needs a adapter like this alpha adapter that I have now with me. So to demonstrate how this works, okay. So this supports monitor mode, that it can listen to the air and it can capture the data, and also it can do packet injection to the network. That means it can so the attacker can create a spoof of the frames, and he can send the frames to whatever he wants. So he can create and he can manipulate the network. Okay, he can send those frames whatever he created manually. Okay, so those frames he can send to the network. Okay, that these are the possibilities that these are the things we can do using a network adapters like this. So if your laptop supports that, then that's good. So he can do that with that. Okay, so what else he need? He need a spoofed deauthentication frame. Okay, so if you observe here, it says spoofed deauthentication. It's a deauthentication frame which consists source address as the same as MAC address. If you observe here, the source address that he created and the MAC address of an access this access point, okay, they both are same. And the destination address, if you see, it's a broadcast address. So now he created a deauthentication frame which looks like coming from the access point. So using this network adapter, he will send that frame to network, okay, completely. So now whoever connected to this access point will get this deauthentication frame. Okay, now every employee in this network will get this frame. Okay, now think that, oh, AP is sending me a deauthentication. Okay, now I have to disconnect. So whoever connected to this access point will be disconnected. because they will think that the access point is actually sending me a deauthentication print. So you have seen, right? So how hackers like this perform these kinds of attacks using their one small script with a Python script and 10 lines of code and using a alpha adapter like this. Okay, so let me show you my setup. Okay, so I hope you can see. Okay, so this is my LAN port I'm using as a client device. Okay, clients I can create using this client, virtual client. So if I want 100 clients, I can create using this LAN port. And this is the access point. All these clients will connect to this access point. Okay, this is white box, open Wi-Fi access point, and using this alpha adapter, I will disconnect all these clients connected to an access point. Okay. That was, hope that was clear. Let's get into the demo. Okay, let me show you the access point interface. Okay, this is my access point interface where I can configure my AP and I can push configuration whatever I want. So from here I configure my AP, this configuration where the SSID is Candela. Okay, and this is the password 1290. Okay, and yeah, this is my configuration, and with this configuration on my AP, I get connected. If you see 50 clients. Okay, so there are 50 clients got connected. Okay, these all are virtual clients that I showed using LAN port I have created and connected to that access point. Okay, got it right. So now using Kali, that where I connected my alpha adapter. Okay, so let me show you that. So this is my WLAN interface is my alpha adapter. So let me enable this monitor interface on this alpha adapter. So right now I'm using a 36 channel, and this is a interface of alpha adapter, and this is the command. Airmon is a tool that we are using. Okay, I have enabled the monitor interface, and so now I need to create a frame, the authentication frame, which looks like a coming from the AP. Okay, so now I have a script the of the file. Okay, you observe here the source MAC. Source MAC is the AP MAC. This is the AP MAC. How attackers will get this MAC? They just listen to the network. So when a beacon comes, that is the MAC address of the AP. Okay, and the destination IP address, if you observe, it is the broadcast address. That means so this frame is coming from the AP and going to everyone in the network, whoever connected to that access point. Okay, this is the whole. This is I have written using Scapy. Okay, attackers we use tools like Scapy to create manipulated frames, put packets. Okay, okay. Let's run this attack once and check these clients, whatever these clients connected, right? So here all these clients will disconnect or not. Okay, if you see this yellow means they are getting the frames, de-authentication frames, they all got disconnected. So even they try to connect back, I have written this script in a loop. So these de-authentication frames will continuously send to the whoever connected to the access point. So even they try to connect back. See now if you see they connected back again, and they will get disconnected. See now again they are getting disconnected. So this is called denial of service. So the attackers like using these tools, they can interrupt your network. They can completely stop your service when you connect an access point. Okay, even so, if you see, if you observe the logs, they'll try to de-authentication is coming, and they'll try to again connecting back. So this is a very dangerous attack. Okay, let me stop this attack. I hope that is clear. So how can we avoid? How can we prevent these types of attacks? There is only one solution for that, using 802.11w. So it is a management frame protection. That means so few frames like dissociation, de-authentication, some channel switch announcements. So once the connection established between the client and an access point, they will exchange the keys, right? So they generate the PDK and GDK, and in this case, they will also generate the IGDK as well. Okay, once they generate, so whatever the management frames should transfer and between the client and access point, they should be encrypted using those keys. So if it is a management unicast frame, that should be encrypted with a PDK. If it is a broadcast and multicast management frame, that should be encrypted using a IGDK. Okay, so not all frames will be encrypted. If you observe, beacon will be not encrypted, probe request, probe response. So those frames will not be encrypted using 11w. So the mainly frames which are dissociation, de-authentication, some action frames which will be generated after for the handshake, like, or else if you observe roaming between one access point to another access point. So in that case, the reassociation frames will be encrypted, right? So few of the frames will be encrypted using 802.11w. Okay, let's check will this work or not. So we don't know, right? So we will perform a test and we'll check how this 11w works. Okay, I will enable 11w on my AP. Okay, let me disconnect all the clients first. 50 clients I'm disconnecting from access point. Okay, and here I can instead of so here if you observe, I have disabled the 11w. Now I will say required. Okay, and save the configuration. Okay, let's up the all the clients. Yeah, the configuration successfully pushed into the AP, and all the clients started connecting. So now these clients enabled 11w. Okay, because AP is saying 11w is required. So whenever you connecting to this access point, so you must enable 11w. So now whenever a client or AP transmits any management frame like dissociation or de-authentication, they will be encrypted. Okay, let's try to run the same attack. Okay, you observe the packets are sending. Okay, so here if you see, the no client is getting disconnected. And how can we verify actually the frame is received by the client or not? So here if you see these Wi-Fi messages, you can see these logs. Okay, unprotected de-authentication is coming from this access point MAC address. Okay, and this is the reason code. So whenever clients sees this unprotected de-authentication frames, they'll just drop, because it should be encrypted using IGDK, because it's a broadcast frame and it should be encrypted using IGDK, else it will drop at the level. Okay, so yeah, this is how we can secure our network. Okay, so other than this, so when 11w is enabled case, still attackers will try to interrupt your network by just flooding a probe request. They will just create using same SCAPI. They will create probe request frames with different MAC addresses. Okay, and they will flood to the network. Okay, I have that script as well. Let me just open. Okay, here if you see, here the source addresses are different. Okay, I mean a lot of so we can add a number of source addresses. So so each time the probe request will be sent to the AP from different MAC addresses. Okay, this will run in a loop continuously. So when AP is performing some performance test, I mean the clients are browsing something. So attackers will run these types of script and interrupt the network. I mean that will cause the performance issues. Okay, so I will show you how this works. Okay, here the packets are sending, right? So using different MAC addresses each time. Okay, it's sending to the network. So if I open a capture file, AP has to respond because whoever it is, so its duty is whenever it gets a probe request, AP has to respond with a probe response by saying its capabilities. Even it's in busy, it's giving priority to some client anything. So it should respond with its capabilities in probe response. So if you see, this is a okay. This is a probe request that is sent by us, okay, and it's a spoofed probe request, okay. And here, if you see, observe this AP is responding every time it gets a probe request, okay. In this case, this will affect the performance of a network. This is called as probe flood, where attackers sending number of probe requests at a time and disturbing the network. Okay, yeah, that is all about denial of service attacks. Okay, and make sure you enable 11W in your networks, in your access point. Okay, yeah, coming to the cracking WPA or WPA2 password, how attackers crack these passwords like pre-shared keys and how they capture, how they get. So that we are going to show how attackers do that types of attacks. Okay, like saying you have an access point and you have a client device, they will get connected and they'll browse something, right? So in the middle, an attacker. So what he just need, he wants to crack the password. That's it. Okay. So in order to crack the password, what he needs two things. One is four-way handshake and the password dictionary. So the password dictionary you can get from the internet, okay, or he can get millions of passwords from the internet, and he can also create his own dictionary by having guessed passwords. He can guess some passwords is the password, and he can have a list, and he can keep this try this attack with the password. Okay, and what else he need? He need a four-way handshake. So when you can see four-way handshake, when client and AP connecting, while connecting, they will exchange the four-way handshake. But in this case, the client and access point already got connected. Okay, he can do two things in order to capture the four-way handshake. So one is he can continuously listen to the network and wait until a client disconnect and connect back. Then he can capture the four-way handshake. Else he can disconnect, like how if 11W is disabled, and he can disconnect the client and access point. Okay, and once the client and access point disconnects, he can stop the deauthentication flood, and they will get connect back, right? So while the access point and clients connecting back, he can capture the four-way handshake, right? So now he has four-way handshake and the password dictionary he can get from the internet. So yeah, once he has that, what happens? How we can crack? So we are here today, right? So how what's happening in the background? Like how these attackers able to crack these passwords, right? So I want to show you that now. Okay, now he has ePort and four-way, that means four-way handshake and the password dictionary with him, right? So he will select one password at a time from the dictionary. Okay, one password at a time, and he will generate a PMK from that. So if you've seen previous sessions, so you will know how to generate PMK from the password. So the PMK will be derived from the password. Okay. So is that enough to say that is that selected password is correct? No, right? So in order to encrypt or decrypt the keys, we need a PTK. So PTK is the key which is used to decrypt or encrypt the packets, right? So in order to generate the PTK, what else we need? We need anons, S-nons, right? So that we get from the four-way handshake that we captured previously, right? So once attacker has all these data, anons, S-nons, source address and destination address, it will do pseudo random function. Okay, so from that function, you generate the PTK. Okay, now how we can verify that the PTK is the correct one, and how we can say that the selected password is one password that is correct password. Okay, so he need verification. So for that verification, he will use MIC that he can get from the four-way handshake that captures. Okay, so now this MIC he will verify the MIC derived MIC from the PTK. Okay, he will derive so that PTK he generated also consists of MIC, and that MIC and this MIC if both matches, that will be the correct password. Else, okay, what if it doesn't? So he has to do the same process again. So the dictionary will contain millions of passwords he can use, and he will continuously check. Check for the correct password. So if he is lucky enough, if he has the correct one in that dictionary, he will get that password. Okay, else he has to he can't crack it. So if it doesn't have it, the password doesn't contain in the password dictionary. Okay, so yeah. So now, so this is called a dictionary attack. So yeah, let's get into the demo how attackers perform these kinds of attacks and crack the password. If you see, yeah, same. I have 50 clients connected, and I'm gonna use for demo. I will use AirCrack and is a tool which is used to crack passwords, and attackers mostly use the AirCrack engine to crack passwords like this. Okay, and here, so first what he has to do, he has to listen to the network until he gets a four-way handshake. Okay, so we will do that, and so in order to do that, this is the command arrow dump ng and the BSS ID, the MAC addresses of the access point, and the output, the equal messages will be saved in a file that is called PSK. And here I am using an interface which I'm not using this alpha adapter. We can also use alpha adapter to do this attack. But so our LAN4 is also support in order to listen and capture the data. So I'm using our LAN4 interface, which is the Moni 7A. Okay, let me listen to the network. So if you see here, this is a BSS ID that we provided. So it is using WPA2 encryption. It can give all the information, what cipher it is using, and the SSID. And also it provides us the information of the client. Okay. Now, so we are what we are waiting for? We are waiting for a equal messages, right? Or the four-way handshake. But if you see here, no client is getting disconnected. We can't even perform 11W, right? 11W is enabled. We can't even perform the authentication attack. So what else we can do? We can disconnect the client manually of the client and connect back. Okay. So once we do that, if you see, we'll get a equal. So now these all the clients got connected back. So we captured the four-way handshake. Okay, for these many clients. Now we have many equal messages. Let me stop this once. Okay. Now I have the four-way handshake. I have the password dictionary also. Let me show you that one. So this is my password dictionary that I have. Okay. I downloaded from the internet, and also I have added my password to that. Okay, and this is the command to actually crack the password. Okay, this is a crack ng command. So what we are in the inputs are the password dictionary. This is the dictionary and the four-way handshake capture. Okay. So once this is done, oh, see, within milliseconds, actually captured the password, actual password. The password is 12345. So if you use passwords like this, the weaker passwords, and it's very for attackers, it will be very easy to crack passwords like this. So so that's why most of you say that use stronger passwords. Okay. And also, if you see that the dictionary that I showed, right? So that the dictionary should contain this password. That is called dictionary attack. So if the dictionary doesn't contain the password, the actual password, so attackers can't crack that. Okay, that's why make sure you use a stronger password. Okay, let's jump back. Okay, that was how attackers crack the password, and now Sainath will show you how these evil twin attacks happen. Right. Okay. Over to you, Sainath.
Yeah. So, yeah, that's a very good demonstration, which we saw previously, right? So the tools are very powerful enough to crack the passwords within few milliseconds. So if you go back to this, so if we please remember this flow chart. So this is how the attackers are cracking the passwords. Right? They are taking the password dictionary, and basically this is just a guessing game. So they will run the password dictionary in a loop, and they will check every time for every iteration whether the password matches or not. And here the password dictionary might be very long, as uses tens of millions of passwords or even more. So as your password dictionary gets bigger and bigger, you need more computational power and more computational resources in order to crack the password. So that is where attackers become very clever and come up with techniques like evil twin attacks. So in evil twin attacks, so initially our client device is connected to the access point. So this is a very basic normal connection. And here comes the attacker, and he will do the same de-authentication to the client. Why? This is just because to capture the four-way handshake, right? So once the client gets disconnected, the client will try to connect back to the access point, and while connecting back, the attacker will parallelly listen over the air, and he will get the keys. He will get the four-way handshake EPOD four-way handshake capture. He will be getting it from the over the air snipping. So now he has the four-way handshake capture, and what does he do? He will disconnect the client permanently to the access point. Now the client lost its access to the access point, and now he will be setting another access point that looks exactly similar to this one in terms of the network SSID that is configured, the MAC address, and he will set up all the other services that a basic access point has. So he will be setting the DNS server in order to resolve your DNS query. He'll also be setting a DHCP server in order to provide you the IP address when you are connected to the fake access point. So the attacker is now ready with his setup, and what happens? So this is how the evil twin attack works. Okay, so he will broadcast a beacon with the same SSID as this get. Okay, the same SSID of your original network, but instead of WPA or WPA2, he will be broadcasting it with an open authentication network. So you might ask, why is he going for an open network instead of WPA or WPA2? Because at this point he is still not aware of the password that is configured on the original network, right? So that is his actual intention in order to crack the password. So he will be setting up an open authentication, and once the user clicks, and he will also be setting up a captive portal. So once the user is redirected to a captive portal, that will be looking something like this. So the attackers has powerful tools. They are powerful enough to replicate the captive portals of actual AP vendors. So here is one of the screenshot where, and it will say, right, it will be very legitimately looking. So the user might think it is pay request from the access point. So here it says, or what does it say? Dear customer, for your security, the gateway requires an update, and please enter your password further router to function. So since he already got disconnected from the access point, he might think this is a legit request from the access point. And so if he is a user like me, initially I would never enter my access password. So what would I do? I would type some gibberish random password. And at that point, what the attacker will do, he will compare this password with the previous equal four-way handshake that he has captured in the initial DO, which we have seen right in the previous slide how that works. Okay, has just demonstrated that. And this, if the MIC verification fails, he will not route the traffic. I mean, he will not grant the access to internet for this user. And at this point, the user gets really frustrated. And if he is in middle of something critical, something very important, let's say you are in a very important meeting, or you are having an exam, or you are doing something very super important on the internet, you would just give up, right? At some point, because you want to access the internet, and you will try two or three more times, and you will think that the victim might think the request is from the original access point, and at some point he will be entering the right password. Okay, and once the right password is entered, he will be again doing the MIC verification, and once it is successful, he will grant the access to internet. So from the user perspective, he will still be able to access the internet, and he's fine. But this topology is very dangerous, right? Because the attacker at this point, he can basically listen to all the traffic that is going on between the user and the internet. And if he wants to modify the data, he can even do that as well. So this is evil twin attack. So, but how evil twin attack is helping the attacker in terms of the previous attack that we have seen. So Gopi has demonstrated how attackers can crack the password, right? So that's basically a guessing game. You take millions of passwords and you check one by one in a loop whether it matches or not. Yeah, if it does not match, and you will leave. So these days we have very sophisticated password manager tools, right? Like LastPass or Google Password Manager. Google has its own built-in password manager in Chrome, and they'll be and if they will be asking suggestions, right? Should I create a password for you? And that will be cryptographically powerful enough that usually we don't do that. It will generate a bunch of random strings which has uppercase letters, lowercase letters, or even numericals and special characters. So those passwords are usually tough to crack, and those are usually tough to find in the online dictionaries that Gopi has showed us before. So in such cases, attackers might use evil twin attack, where he will do kind of social engineering on the victim, thinking that his original access point is going under firmware upgrade, so he needs to enter his password. So the computational requirement got reduced here, right? Instead of iterating over tens of millions of passwords, here you are just iterating over the passwords that are being entered by the user himself. So if he enters only 10 passwords, you are just iterating those 10 passwords and you are just checking. And if the password matches, you have got the access to the network. So this is how the basic attack works. And the attackers have tools like Aerodon or Flexion, or he'll also use APEC in order to crack the password and all. So we have seen very scary stuff, right? Till now, there are lots of attacks that we have seen, but can't we protect ourselves from all these attacks? Surely we can. So we'll be looking at some of the precautionary measures in order to protect ourselves from these kind of attacks. So Gobi will be walking us through some of the precautionary measures.
Yeah, thanks, Sainath. Yeah, this is very important for us, how to protect ourselves from these types of attacks. So some of them are very dangerous. Some of them, yeah, they will disturb the network, they will interrupt the network. But yeah, how we can prevent these kinds of attacks, right? So I hope most of you are here to know how to prevent instead of cracking a password. Okay, the first basic one, avoid connecting to a Wi-Fi hotspot that are unsecure. So if you see an access point which is broadcasting open security, and do not go and connect to that access point. So if you observe rogue access point, so some attacker sitting next to you can create that access point, okay, easily. And if you connect to that, That's it. All your data, sensitive data, password, anything he can see, right? So first thing first, try to avoid connecting to open authentication access points. Okay. So if you have an emergency, if you really need to connect, then try to use VPNs. There are many VPNs available. Some of them are very best. So they will encrypt. They will create a tunnel between you and a VPN server. So hope that will somehow will secure your data. So and if you can't, some of them are paid. So if you can't able to afford and if you can't able to use VPNs, at least try to browse HTTP websites only. Okay, so that will take care of TCP or UDP. So HTTPS will encrypt your data, right? So even if you do security at L2, and HTTPS will take care. Okay, so yeah, if you use HTTP and you still connected to open network, then all your data will be sent to the network, will be visible to everyone. Okay, and then attackers can easily capture and they can see what you're actually doing, right? So this is from the user side. So client side. So who are going to connect an access point? So basically, should follow these things to prevent the attacks. Okay, and so whoever deploying an access point in a network and in your home router or else in an enterprise network, make sure you use the latest security. Okay, latest Wi-Fi security like WPA2, WPA3. So if it is an enterprise, make sure you use a radius server as authentication server, and so if it is a home router, make sure you use WPA2 or WPA3 personal. Okay, and so that how I showed, right? So one, if you use a password like 123456789, then that will be available in the internet dictionaries, password dictionaries. The attackers can easily crack that. Okay, make sure you use stronger Wi-Fi password. Okay, and some of the clients will leave I have seen lot. So in a home routers they will leave default admin home page, right? Home page of the router. So leave defaultly. Okay, they will not change. So that will give an attacker to actually access the network. Okay, so make sure you change your default credentials of admin home page. And yeah, you have seen that, right? So enabling 11W will prevent denial of service attacks. Like, so if you're an enterprise, then you must enable. So if you use the WPA2, keep it optional. So some legacy client will can come and connect. But whenever you are using WPA3, so 11W is mandatory. You can't disable the 11W in WPA3 security. Try to enable 11W to protect management trends. Okay, and setting up a radius server. So make sure if you're in an organization and you must need a radius server to authenticate the client. Okay, that will give a different PMK every time a client connects. Okay, so instead of sharing the same password to all the employees, make sure you use a radius server for a different username and field. Okay, and implementing TLS. So we have different methods in methods. Okay, like TLS, TTLS, and PEEP, right? So TLS is more secure, so where it exchange the client side certificates, and server will also exchange its certificate. So it will be very secure to authenticate your client. And use IDS systems. So it will detect. So when an attack happens immediately. So yeah, using IDS in an enterprise network very useful to detect an attack immediately, and to prevent and to check and so some IDS will prevent the attack before happening. So make sure you use IDS systems to detect. Okay, MAC filtering. So if you in your enterprise network, if you have a client or well-known clients, and you add those MAC addresses in your router and give only access to them, so that will will prevent others to connect to your network. Okay, yeah, these are the some methods we follow to prevent wireless network attacks. Okay, here are the some of the references that you can go and check.